Hey everyone, and welcome. Today we are going to talk about a concept that will totally change how you write code. It's called inheritance. Seriously, it's the secret to writing less code, but doing way more with it, and building programs that are just cleaner and more powerful. So, you ready to level up your coding game? Let's dive in.
First, let me ask you a quick question. Do you ever get that feeling? You know the one, that déjà vu when you're coding. Like you've written this amazing piece of code, and then, a little while later, you find yourself just copying and pasting it somewhere else. It feels kind of clunky, right? Well, you're not alone, and today we're going to break that habit for good.
So that brings us right to what I call the code copying problem. It's a hurdle pretty much every single developer runs into, but really seeing it for what it is, that's the first step to writing much, much smarter software.
Okay, let's paint a picture. Imagine you spent time building this perfect calculator class. It's beautiful, it just works. But now the next project needs an advanced calculator. That urge to just copy all that code and paste it into a new file is super strong, I get it. But what happens when you find a tiny bug in your original add function? Uh-oh, now you have to fix it in 2 places. And if you copied it 5 times, it becomes a total nightmare to maintain. There is a much better way.
And that better, more elegant way is built on an idea we all get without even thinking about it, the relationship between a parent and a child. So let's unpack what's really going on here.
You know this quote right here? It's perfect. In the real world, children inherit things from their parents, right? They get their DNA, their traits. They don't have to figure out how to walk or talk from scratch. It's kind of part of the package. Well, in programming, it's the exact same idea. A child class can inherit the DNA, the code, from its parent.
Okay, so what's the official textbook definition? Inheritance is just a way for a new class, the child, to automatically get all the features and behaviors from an existing class, the parent. And the absolute best part? The child gets all of this functionality for free, without you having to rewrite a single line of that original code.
Okay, so we get what it is. But the million-dollar question is, when do you actually use it? Well, the secret is a super simple but really powerful test. I call it the is-a relationship. All you have to do is ask yourself, is my new thing a type of my old thing?
And this is super important. It lays it all out. An advanced calculator is a calculator, right? It does everything a basic one does, plus more. A laptop is a computer. That is a connection. That's your green light, your signal to go ahead and use inheritance. Now, on the other side, a house has a TV. A house isn't a type of TV. That's a has-a relationship, and we use a different tool for that. But for now, just burn this into your brain. Inheritance is for is-a.
All right, enough theory. Theory's great, but let's see how this actually works in practice. Let's take that is idea and apply it to our calculator example and see what this looks like with actual code structure. So here's our starting point, our parent class, the good old calculator. It can add, subtract, multiply, and divide. We've written the code, we've tested it, we know it works, it's solid. This is our foundation. And here, this is where the magic happens. All we have to do is declare that our advanced calculator is a child of calculator. In a language like Python, it's as simple as typing class advanced calculator, calculator, and bam, instantly it gets all of its parents' powers. No copying, no pasting, no extra work. It's honestly like getting a superpower for your code. So now, we don't have to worry about the basics. They're already there. We can just focus on the cool new stuff. We can add our special features, like a power function or a square root function. We're reusing that solid foundation, and we're just extending it with new abilities. And that right there, that's how you write smart code that's easy to build on. Okay, you've totally got the idea. Now let's learn the lingo so you can talk the talk. Knowing these official terms will definitely help you in exams or job interviews. And frankly, it just makes it easier to understand what other developers are talking about.
Think of this table as your little cheat sheet. The class that gives the features is usually called the parent class, but you'll also hear Superclass or Base class. The one that receives them is the child class, but it's also called the Subclass or Derived class. They all mean the same thing, so don't let the different words throw you off.
So what's the big takeaway? Why should you care so much about this? Well, it really comes down to 3 huge wins. First, code reusability. You write it once, you test it once, and you can use it all over the place. Second, way less redundancy. If you find a bug, you fix it in one spot, the parent, and it's fixed for all the children automatically. And third,
It just gives your code a clean, logical structure that makes sense and is so much easier to understand down the road.
And that is inheritance in a nutshell. But before you go, I want to leave you with a final thought. This whole parent-child pattern, it's not just for code. You'll start seeing it everywhere once you look for it. In file systems, in user interface design, it's a fundamental idea. So my question to you is, where are you going to use this powerful idea to build something incredible? Thanks for joining me.